What is work? There is a difference in the way we use the term work in day-to-day life and the way we use it in science. In everyday talk, work means effort. But in science, work is about moving things. For example, pushing a rock with all your strength does not count as work if it does not move. Climbing stairs count as work because you are moving yourself and going against gravity. In the world of science, we cannot base our explanations on perception. All the words must be properly defined using clear terms and parameters for which all agree. So let us first understand what work actually means in the world of physics. In scientific terms, work is defined as the measure of energy transfer that occurs when an object is moved by an external force along a displacement. It is the product of the force acting on the object and the distance it is moved in the direction of the force. Let us try to understand by using few simple examples. Throwing a bowling ball, pushing a boulder, pulling a trolley are all examples of work done in physics. So always remember, in science, work is done when a force moves an object a certain distance. It is considered no work done if carrying a heavy load without moving it, even if it makes you tired. We will discuss it mathematically to understand why no work done is considered in this case. Mathematical expression. Now, we can say that work is defined by two numerical parameters as seen from the definition. Force. Displacement in the direction of force. So, formula for work done is force, F, times displacement, S. The SI unit of work is joule. It is represented by the letter J. Let us try an example. You push a box with a force of 10 newtons and it moves 5 meters, then the work done is 50 joules. It is now easier to comprehend why carrying a heavy load without moving, much like a statue seller who bears the weight of his goods on his head all day, is considered as doing no work according to physics. Isn't it unfortunate? Let's discuss why this is so. It is because since the goods are on his head and are stationary, they are not moving, therefore the distance covered is zero. Therefore, work, which is force times displacement, is zero. Force at an angle. So according to the formula, if we try to apply vertical force on a block and it moves horizontally, is it considered work done? The answer to this question is a big no. The reason is simple enough. Let us revise the definition of work once again. See something interesting? Yes, there is a little catch to the second condition. It states that displacement is in the direction of force. In the current scenario, force and displacement are not in the same direction. Hence, there is no work done. Imagine a scenario in which instead of pushing the box horizontally or vertically, you decide to push it at an angle of theta degrees upward from the horizontal direction. From common knowledge, we know that the complete force is not causing the motion of the box. Only a small part of the force is responsible for motion. To find the value of this part of force, we use the angle between force and displacement. So now, we can generate a universal formula to calculate the work done as work is equal to products of force, F, displacement, S, and cosine of the angle between them, cos, theta. Now let us try to solve a problem. You are pushing a box at an angle 60 degrees from horizontal direction. The box moves 5 meters horizontally, but now the angle between the force and the displacement is 60 degrees. To calculate the work done in this case, use the formula W is equal to F times S times cos theta. Here, F is still the force, 10 newtons, S is the displacement, 5 meters, and theta is now 60 degrees. The cosine of 60 degrees is a half or 0.5. Therefore, the work done is W is equal to 10 times 5 times 0.5, which is 25 joules. Types of work done. Now, let us understand how to represent different types of work done. Work done can be positive, negative, or even zero depending on the angle between the force and displacement. Let's explore these with examples. Positive work done. When the angle between force and displacement is acute, that is, angle is less than 90 degrees, the work done is positive. A gardener pushes a lawn roller through a distance, applying a force at an angle theta degrees to the ground, which is an acute angle. The work done by the gardener is force times displacement times cos theta, and it is positive. Zero work done. When the angle between force and displacement is 90 degrees, the work done is zero, as work done equals force times displacement times cos theta, and since cos 90 is zero, hence work done is zero. Imagine lifting a book and placing it back on the same shelf. If you lift it up and then put it back down without moving it horizontally, the work done is zero because there's no net displacement in the direction of the force applied. For a body moving in a circular path, the work done by the centripetal force is zero since the force is perpendicular to the displacement. Negative work done. When the angle between force and displacement is 180 degrees, as cos 180 is -1, so the work done is negative. This often occurs when dealing with friction. A block is pushed by a force and displaced through a distance. The work done by the applied force is positive, while the work done by the frictional force is negative, as the frictional force works opposite to the direction of displacement, and hence the angle between the frictional force and the direction of displacement is 180 degrees. Work done is maximum when the angle is 0 degrees, as work done is force times displacement times cos theta, and as the value of cos 0 is 1, hence work is force times displacement only, which is the maximum work done, and it happens when the force acts in the direction of the displacement. Conclusion. In physics, work is a dance of forces and movements involving push, pull, and angles. It's the story of how energy moves when we push, lift, or deal with obstacles like friction. We hope that you have understood the concept of work. Now, here's a secret on how you can study effectively with the EduRev app. You can learn with chapter notes, watch video lectures, and solve NCERT-based MCQ tests of this chapter on EduRev. And that's not all, you also get amazing courses for Class 9 and much more for your Class 9 preparation. Thank you.